Okay, continuing problem 1, part F says find the value of x when the height of the water in the tank is 0.9 meters. Okay, so now they give us the height of the water, which we just covered in part E is a y value. So we're going to plug 0.9 in for y and solve for x. So 0.9 would equal 0.2x squared. So then we would want to divide both sides by 0.2 to get the x squared by itself. And 0.9 divided by 0.2 comes out to be 4.5. So we have 4.5 equals x squared. Then we take the square root of both sides to get rid of the squared. And the square root of 4.5 comes out to be about 2.12. So when the height of the water is 0.9, the width of the water is about 2.12 meters. Okay, before part G, it says the water tank has a length of 5 meters. Letter G says when the water tank is filled to a height of 0.9 meters, the front cross-sectional area of the water is 2.55 meters squared. Part 1 says calculate the volume of water in the tank. So if we go up to the picture of our tank, okay, if you think about the shape of the tank, that shape is a cylinder cut in half. Now if I go to my formula booklet, the volume of a cylinder, which is here, is pi r squared h, where r is the radius and h is the height of the cylinder. Now if we apply that to our problem, okay, we need to think three-dimensionally here. Let me write down the equation. V equals pi r squared h. R, which is usually the radius of the cylinder, in terms of our problem, would be the height of the water. And h, which is usually the height of the cylinder, in terms of our problem, if I were to stand up the cylinder, so it was standing up straight up and down, the length of our cylinder in this picture would be the height of the cylinder. So h really represents the length of the tank. So now that I know that the height of my water is 0.9, and they just told me the water tank has a length of 5 meters, so I can plug those into my equation and solve. So V is pi times 0.9 squared times 5. And if we type that into the calculator, we can round to 3 sig figs. It comes out to be about 12.7 meters cubed. So then it also says the total volume of the tank is 36 meters cubed. And part 2 says calculate the percentage of water in the tank. So since our tank is only filled 12.7 meters cubed, what we would do is we would take that, divide it by the actual total volume of the tank. 12.7 divided by 36 comes out to be 0.353. And if we multiply that by 100 to turn it into a percentage, we get that the tank is only filled 35.3%.